Welcome to class tonight. Tonight we're going to be expanding our understanding of probability. Now in class we talked a lot about probability, we introduced the idea. Tonight we're going to talk about a specific type of probability. You can see that on the board right there. We're going to be talking about what's called experimental probability. Now in class we worked without trying anything. Okay? We didn't do any examples, we just kind of did, it was all very, the word is theoretical. It all happened really in our head. Tonight, however, we're going to talk about experimental probability, and experimental probability is all about the work, or creating actually an experiment. You can hear the word experiment and experimental. Tonight we're going to be looking at data, not simply possibilities. We're going to be looking at specific examples. Now I would strongly encourage you to go ahead and open your book to page 553. That's where this is listed out. We're actually going to be going through some of the key concepts from page 553 and then later pages, and then moving through the examples. So go and open your books to page 553. All right, so now we see the formula. This is the key concept on page 553. We see the formula on the screen there. All right, now this you should remember from today in class. Okay, this simply means the probability of the event. Okay, so that's all we're saying. Probability of the event equals the number of times an event occurs and then the total number of trials. Now, for example, okay, this is my example right here. Now, my probability, say we're flipping a coin. Okay, we just have a coin in our hands and we're just flipping it, flipping it, flipping it, flipping it. Okay, say I flipped it 50 times. Okay, so that's the total number of trials. Well, every time it came up heads, it was 26. So I counted, and every time it came up heads, there were 26 times. So we would say the experimental probability for heads is 26 50ths. Now, I would actually go ahead and reduce that. Okay, so you could reduce that, so you divide both sides by 2, and you'd get 13 25ths. So we would say the probability for heads would be 13 25ths. Okay, that's the probability of this event. So that's the example. Number of times an event occurs over the number of trials. All right, let's put it to practice. Now this is example 1 on page 554. Okay, this is example 1 on page 554. All right, so it says, the question is, or we're doing tennis now. In 20 tennis matches against Jeannie, Eileen wins 9 times. So we would say the experimental probability, so there were 20 matches, so that's 20 at the bottom, and she won, so the probability of Eileen winning is 9. So we'd say the probability of Eileen winning is 9 times. Now the question is, what is the experimental probability that Jeannie wins? Well, if Eileen won 9 times, that would mean Jeannie won 11 times. So it's going to look like this. We're going to put our total number, so that's 20 right here, our total number on the bottom, and Jeannie won, right here, Jeannie won 11 times. So our experimental probability that Jeannie will win is going to be 11 20s. Now let's go and do one more example that's actually very similar to that last one. It says, Franklin and Tom play 30 matches. Franklin wins 12 matches. What is the experimental probability that Franklin wins a match? So a couple key numbers. I see 30 matches, and he wins 12. Okay, so the probability that Franklin will win is going to be our bottom number, our total number of matches is going to be 30. And our top number is going to be 12, because Franklin won 12 matches. Now, as with all fractions, always reduce. Always reduce. So let's go ahead and reduce these. I'll divide both sides by 2. That's going to be 6 15ths. Now I can divide by 3 each. That's going to be 2 fifths. So there we go, ladies and gentlemen. The experimental probability that Franklin will win a game is going to be 2 fifths. Now I want to pause real quick and say that this looks back here, this right here, this looks pretty complex. Okay, it looks kind of scary. But I hope you've seen, now that we've done 2 examples, that it's actually very, very easy. It really isn't that difficult. All you have to do is be able to basically put the right numbers in the right places and then be able to reduce. It's very simple like that. All right, there is one more example with another another part. Now we're going to be talking about fair games. If a game that we play is fair or not. So let's go ahead and read this. You and your friend want to play a game, but your only number cube is chipped. It's beat up a little bit. To make a fair game, you first roll the cube 60 times and then record the results. Which of the following games seems fair? Alright, so key numbers right here are 60, so that's the total number of trials. So I automatically know my bottom number on all these experimental probability problems is going to be 60. Oh, I did forget to mention, this is example 2 on page 554. Example 2. So I would encourage you guys to look at that very quickly. Alright, so I see a chart here then. I see my outcomes. So every time they roll a 1, there was 16. They rolled a 2 17 times, rolled a 3 12 times, rolled a 4 8 times, rolled a 5 4 times, and rolled a 6 3 times. So we can see just from the chart, there is a much higher likelihood that we're going to get one of these 3 numbers as opposed to one of these 3 numbers. Okay, so we can automatically tell that just off the bat that there's a greater likelihood we're going to get one of the bigger numbers. Alright, so let's go ahead and look at these examples. I'm going to scroll down a little bit. Alright, so the first one. So the first game is you win with a 6 and your friend wins with a 2. Now to see if this game is fair or not, all we have to do is create the experimental probability. That's all we're going to have to do. So remember, my bottom number is 60. My top number, so 6, rolled a 6 3 times. So the probability of U is going to be 3 over 6. Now I'm going to reduce that, and that's going to equal 1/30th. Sorry. No, I'm sorry. 1/20th. Okay? 1/20th. Alright, so now the probability your friend will win, so probability of friend, I'll put probability of F. Probability of F for friend is going to equal, so 2, so that's total of 60 times, and 17. Now ladies and gentlemen, looking at these 2 different probabilities, 3/60ths, or 1/20th, same thing, or 17/60ths, it is much more likely that your friend is going to win this game. That's not a fair game. The probability is not the same. That's what makes a game fair, if the probability is the same. And so this is not a fair game, because the probability for you winning is 3 out of 60. The probability of your friend winning is going to be 17 out of 60. So that's unfair. Alright, so let's keep on going. Let's see what this next one is. If the number is even, you win. If the number is odd, your friend wins. Alright, so let's see. So even numbers, so PY, that's probability for you, is going to be, so I have, even numbers are going to be 2, 4, and 6. So I have 17 plus 8 is going to be 25, 6, 27, 28. So it's going to be 28 over 60. Remember, there are 60 trials. 17 plus 18 plus 3 is going to be 28. The probability of your friend winning is going to be, so 16 plus 12 is going to be 30. Is that right? No, sorry, 28. 28 plus 4 is going to be 32. And there we have. So the probability for you is 28 over 60, and your friend is going to be 32 over 60. So while now that's not exactly perfect, that's much closer. 28/60ths and 32/60ths are much closer than this previous game. So while this game is not fair, we would call this game fair because the probabilities are much similar. Alright, there is one more. You win with a 3, 6, 1, 3, 6, and your friend wins with a 2, 4, or 5. So once again, let's go ahead and add those up. So probability of you winning is going to be, so 1, 3, and 6, so 16 plus 12 is going to be 28, plus another 3 is going to be 20, 29, so 31. 31 over 60, because remember our 60 is our bottom number. And then your friend wins with a 2, 4, and 6. So 2 and 4, it's going to be 25, and then a 5. 25, that's going to be 29. So, and once again, this and this are very close, so we would call that a fair game. All right, ladies and gentlemen, that is the lesson. The key tonight to remember is that with experimental probability, we are looking at data. So you have to look at the data. What does the story problem say? What does the problem say? Then you can determine the probability. Remember, all you got to do is use that formula. The bottom number is total number of trials. Top number is the number of successful trials. And that's it. So your homework tonight is page 555, 2 through 10 even. Once again, page 555, 2 through 10 even. Have a wonderful night. I'll see you all in the morning.